Okay, this is video 6C, and we're going to start doing some examples with our arcs and chords in this one. So in example 3 comes from your textbook here. It says circle O has a radius of 13 inches. So what I would do in this diagram as I have this in front of me is I would start by making sure that I know that this dotted line right here is a radius, and I would put the measurement that I was just told onto the diagram. So that's 13. And I don't know about you, but I see that piece right there as part of a right triangle, and specifically it's the hypotenuse of the right triangle. So we're going to keep that in mind as we read through the rest of the problem. We're told that OB is perpendicular to chord CD, which we've got marked, and that we're told that the chord CD is 24 inches long. So in this situation, we've got a right angle which is going to bisect that chord. Remember, the radius drawn to the chord at a right angle bisects it. So since the chord is bisected, we're just going to say that the measure of the distance there is going to be the same on either side. So that's important for us to know as we get to through this problem. So let's see what we're being asked to find. If the measure of arc CD, and make sure you put the arc symbol there, is 134, then we need to find the measure of arc CB. So you need to recall that the measure of CB is, because it's bisected, actually the arc is bisected as well, and so that's going to be equal to half the measure of arc CD. And if CD is 134, then we're looking at half of 134 and getting our answer of 67 degrees. Next thing we want to do is we want to find OX, and looking back at the diagram, that's this piece right here. So guys, what I would do at this point is I would redraw part of this diagram so that it's not part of the circle, but that you've still got the measures. So I'm looking at the right triangle here in the middle where this is corner X, this is the center of O, and this angle up here is C. And if I do that, I think of the measures that I know as 13, and if the chord, which was 24, is bisected, then that means CX is 12, and what I need to do is find OX. So I think I see a right triangle here. We're going to be using Pythagorean Theorem. So if I think about OX and I square it, plus the other leg squared, which is 12 squared, then that has to equal 13 squared. So OX squared, if you will, plus the 144 has to equal 169. And then I have OX squared is going to equal 25. So pretty simple, just do a square root. OX, oops, not 25. OX has to be just 5, you guys. So I also want to remind you that another way to think about this situation, rather than using the Pythagorean theorem, is to remember the idea of your Pythagorean triples. If you think of what we had as a list, this is a 5, 12, 13. So if you think about the pieces that you have to begin with, if you know one is 12 and one is 13, then if you know your triples, the other missing one would have to be 5. It just saves you some time. It's not necessary, but it does save you some time. All right, let's go on to the next example that's kind of like that, using the idea of a chord that is bisected. This one is not in your textbook, but it's similar to what we just did. So circle W has a radius of 10 centimeters. Now notice the radius isn't drawn in on this problem, so it might be a pretty good idea for us to do that. Let's just draw in from W to H here, and let's label that as 10. Radius WL, we're told, is perpendicular to chord HK, and we're told that that chord is 16 centimeters long. So since it's being bisected, we know that we have an 8 here and an 8 here. And we are also told that in part A, if the measure of arc HL is 53 degrees. So that's, I'm going to put that outside kind of on the arc itself, is 53 degrees. Then we want to find the measure of arc MK. So because the chord is bisected, remember the arc is also bisected. So my LK arc there is also 53 degrees. And we're going to remember that from M all the way to L is also known as a semicircle. So that's our magic number 180. And so I'm simply taking that 180, subtract off the 53 that I know LK is, and I get 127 degrees. Now if we want to find the length of JL itself, again it might help to redraw this diagram here. So I'm going to pull off the right triangle piece at J with a center at W and over here on the circle at H. And point L is somewhere down here. That's not really part of the right triangle, but that is really what we're solving for, essentially. So we're going to need to know that eventually. So since the radius is 10, and notice the radius could go from W to H here, or it could also go from W all the way down to L. And so this whole distance right here also has to be 10. That's an important thing to remember. But now we've got some labels. We know HJ is 8, like we said, with the bisected chord, and we've got our radius is 10. So I think what we need to start looking for is WJ. And we can do Pythagorean Theorem there. So WJ all squared plus the 8 that we know is squared has to equal the 10 squared. And WJ squared, just doing some simplification, has to equal 36, which leaves WJ to be equal to 6. So remember, we found that this is 6 here, but what we need is what JL is. So we're going to just do a quick subtraction because JL plus the 6 that we just found equals the full 10 radius. So JL has to be 4. So that's what we're looking at for those two examples, which are a radius drawn perpendicular to a chord. On the next page here, we're going to be looking at when a chord is equidistant from the center. And so we're told here that AC and DF are equidistant from the center. You can see their distance is marked as 10. A reminder that when we're talking about equidistant, that is always a case where distance is measured at a 90-degree angle at right angles. Okay, so we can go ahead and zoom in here on this picture and add some labels to this. That means that this is a right angle and this is a right angle. So I think you can see probably the Pythagorean theorem that's going to come back at us here. It says if the radius of G is 26, we're going to find AC and DE. Okay, so find AC and DE. If I put the radius is 26, I'm going to use this top triangle here of AG is 26. Then I've got a chord that I know that I can find of AC here by first finding the length of AB. Okay, so we've got a right triangle where I know 10, and I know the hypotenuse of that right triangle is 26, and I'm being asked to find AC, but first I would need to know AB to get there. So if I have AB squared plus 10 squared equals 26 squared, then I can do AB squared with some simplification equals 576, and taking my square root, I get AB is actually 24. So remember, AC is going to be twice that because it's the entire chord length, not the bisected piece. So AC is going to be 48. Now we're going to find DE, and if you remember that DE on that picture is the same thing as the bisected chord, which is the same distance as the chord on the other side, then we can say that AC is the same thing as DF, which we know is 48. And so if half of DF is equal to DE, then DE has to equal 24. Okay, and just a reminder about this problem, if you didn't want to do the whole Pythagorean theorem through there, we have another Pythagorean triple that's at play here. And that Pythagorean triple is, if I knew the 10 and the 26, remember those have a common factor of 2. So if I were to divide that by 2, the 26 would become 13. The 10 would become 5. And if I didn't know what that other side was, but I did know my 5, 12, 13 triple, then that means that this part is based off of the 12. And going back, I would multiply by 2, so that would get me my 24. And that just saves a little bit of work for you, that's all. Okay, our last example in this video is one that does not come from your textbook, but we're still talking about chords being equidistant from the center. And I'm looking at example 4B, actually this should be. Sorry about that. But this is chords EF and GH, we're told, that are equidistant from the center, and what we need to do is find PR and RH. So what we are told is that the radius of this circle P is 15, and again, it's not drawn on the diagram, so let's add it in, that the radius is 15. From P, I'm going to go all the way over to F here, and that is 15. We're told that EF, the chord, is 24, and when we have a radius that is drawn to a chord and it's equidistant, remember we can assume that distance is measured at a 90-degree angle, so we can assume that when it's perpendicular like this, our chord is bisected, which means the 24 gets cut in half to 12 on either side. And the 12 on the QF side there, if we redraw the picture, means we have a 15 here, we have a 12 here, and we have the labels as such. So again, we've got Pythagorean theorem at play. If we want to find PR, PR is going to be the same distance away, obviously, as PQ. So let's start by finding PQ, or QP, if you will. I have QP that I'm going to square plus 12 that I'm going to square, which is equal to 15 that I'm going to square. QP squared, doing some simplification again. If we subtract here, QP squared is going to be 81. And so that easily makes QP equal to 9. And of course we said QP, because it's equidistant, is the same as PR. And so we get 9 there. Then we want to talk about RH, but we were told, remember, that EF and GH were the same. So half of each one should also be the same. QF will be the same as RH. And we already know that QF is 12, so RH is going to be 12. Again, thinking Pythagorean triple here. If we knew our Pythagorean triple, and we knew we had a 12 and a 15 as sides of our triangle. We didn't know what that side was, but we saw that each one of these had a common factor. The 12 and the 15 have a common divisor or factor of 3. And if we thought about dividing by 3, the 15 would become a 5, and the 12 would become a 4. And if we knew our triple, 3, 4, 5, we can go ahead and go backwards from the 3 to multiply by 3 again and get back to 9. Again, just another short way to think about this Pythagorean theorem problem. Saves you a little bit of work. Really, really think about memorizing those triples, okay? And that's the end of our video for today. You need to complete the On Your Own yellow page that follows this page in your WISC packet, and I'll see you guys tomorrow.